Hi guys, I'm continuing work on my Westinghouse radio project because since I don't have the parts yet to repair my CRT tube tester, and therefore I cannot continue, well, not exactly continue work on my Philco Safari project. Well, in the meantime I got the parts to rebuild the original capacitor that was fitted into the Westinghouse. I mean by that the electrolytic capacitor. Now I emptied the cardboard tube that originally contained the electrolytics inside the Westinghouse, and I'm going to replace the original electrolytics with the two long and thin electrolytics I bought and one small one, which you see here. This is a 60 microfarad 400 volts, and this is a 47 microfarad 450 volts, which is ample because the original electrolytics were rated at 150 volts, which is plenty good. And then I will use this 250 microfarad actual capacitor rated at 25 volts, whereas the original one was rated at 15 volts. So that should do well too. And as you can see, if I try to insert the capacitors into the tube, there's no problem at all. They all fit inside the tube. To the point where everything or nearly everything in the Westinghouse has been replaced. I mean, most of the resistors have been replaced, all of the capacitors have been replaced, and and by the way, this little forest of capacitors is just there temporarily to make sure that the capacitor network I built isn't the culprit in this radio not functioning. So after having ruled out most of the circuitry and the individual components forming the Westinghouse chassis, I've come to the conclusion that most probably I'm not getting any radio station out of it because of the IF cans, and more specifically because of the capacitors inside the IF cans. Now, basically, if you want to work on the IF cans in circuit, it might be possible, but it's going to be a heck of a job. So I made a stone of my heart, and I decided that I would unmount one IF can at a time, and then replace the capacitors inside the IF can, then remount the rebuilt IF can, and then unmount the other IF can and do the same thing. Now, the reason why I'm not really very fond of doing this is because I need to disconnect all the components and all the leads going to the IF can contacts. But, well, I mean, in this case, I really don't have a choice. So that's exactly what I'm doing right now. The only thing that needs to be disconnected from the left IF can, from this one, is this white wire you see here. So this wire needs to be disconnected, and then when that is done, I can slide out the IF can or slide the IF can away from the chassis. Now, these IF cans are not attached with screws or anything to the chassis, but with a kind of brass clips. And you see it on the other IF can. You see one clip like this. Now the thing you need to do to unmount the IF can is to pull away this clip away from the aluminum case of the IF can. And you do it on the other side. So there are two of these clips. Then you unsolder. Well, actually you can leave the clips on and unsolder the can first and then pull away the clips, which is probably safer. Once you pull away those clips, you can lift that brass clip a little bit, and I mean by lifting I mean you pull it away from the chassis a little bit, and then normally you could slide out the IF can or slide the IF can away from the chassis. Okay, I disconnected all the components and all the wires, as you can see, from the circuitry of the IF cans. Whoops. So there you have a close-up. So now I'm getting ready to pull away the IF can from the chassis. As you can see on top of the wait a minute, let me wedge the chassis a little bit better so I can reach it. Okay, obviously you're going to have to work with a piece of foam to cushion the chassis because, well, you know, it just protects the weaker parts like the tubes and everything. So, okay, you see the clip on top of the aluminum can. You see it there. So what I'm going to do is I'm going to take, I'm going to take a small screwdriver, a flat-ended screwdriver like this, and I'm going to slide it under the clip, and there you go. I just slightly lifted this and it let loose of the IF can. Okay, so let me drop back my screwdriver. So now I disconnected the IF can. I should be able to slide it out of the chassis. Yeah, and here it is. Okay, so now let me put the chassis into a safer position first. Okay, there you go. Okay, so here is the IF can. Now, to open up the IF can, what you need to do is quite simple. Hang on. You see two little aluminum tabs. You see one here, and if I turn around the IF can, you see another here. Yeah. So I need to lift those tabs away from the foot of the IF can, and then I can open. Okay, here is the IF can that I unmounted from the Westinghouse. Now, if you remember, if you watched my other series on refurbishing and repairing the Motorola, the 5T13P Quasar Motorola, the IF cans on the Motorola were certainly a bit taller, and perhaps, but I think the print was square and was certainly not much bigger than this, but they were quite a bit taller. Now that I have it in my hand, I can also tell this IF can is much heavier than the one in the Motorola. Okay, so if you remember, the IF cans unfortunately were built quite cheaply, in the sense that there are just two coils inside built around a column, and at the base of the coils there are capacitors, mica film capacitors, but unfortunately, to save money, those capacitors were built into the base of these IF cans. And if I'm not mistaken, if you watch the bottom of this IF can, let me put on some light. If you watch the bottom of this IF can, you can see at least on one side something silvery. So not where that black or blue end is, but on the other side. Now, I'm pretty certain that that silvery thing that you see is the mica capacitor. So our final goal will be to remove that capacitor and replace it by a normal capacitor. I mean by that a small capacitor but with connector leads. Okay, so let me open up this IF can while you're watching. Okay, so remember there are a number of tabs. Well, there are 2 tabs on this IF can. You see 1 tab here. So I'm going to slide a small screwdriver underneath it like this. Okay, so I opened up the tab on the bottom here, this one. So now I'm going to do the same thing on the other side, but before I'm going to remove the foot of the IF can from the can itself, I'm going to mark its position with an alcohol pen. Remember, alcohol marks you make with an alcohol pen can always be removed easily afterwards with some alcohol. Okay, so I'm going to place a red triangle here, yeah, like this, and I'm going to place a red triangle here, like this. Okay, so that way I can always find the direction in which the capacitor base or the IF base was mounted in the IF can. Okay, so now let me lift the other tab. Alright, so I slide the screwdriver under the tab like this and push it like this. Okay, so now I push the tabs away from the foot. So now, technically speaking, I should be capable of lifting the IF coils out of the IF can. So let's give it a try. Yeah, it's moving all right. So I'm just pulling.
What I find a problem with actors is that their attitude is often sort of, what do you want me to be like?
Yes, and there it is.
Well, just be like you are.
Okay, so these are the IF cans, or IF coils I should say, the way they are built. And once again, what I meant to say is that oh, and by the way, I marked the tip of this IF coil. I don't know if you can see it, but let me switch on the light again. So I marked the tip of the IF coil assembly here with a little bit of blue marker, you know, alcohol marker, and I did the same thing at the top of the IF can. But actually, you know, it's not really essential, since I also marked the foot and where it should be inserted into the IF cam, you know, with a red mark. Okay, anyway, so this IF coil assembly is definitely different from the IF coil which was mounted in the Motorola. As you remember, the Motorola had coils around the tube, and inside that tube there were ferrite cores, and you could turn the cores around to make them slide deeper or out of the tube, and therefore influence more or less the coils which were wound around the tube. Now here, this is completely different. In fact, the coils are still mounted on a central core, but the ferrite, let's say, cores which influence the permissivity of the coils are outside. In fact, they are more or less like caps, if you can see it, you know, and on top there's a slot. Let me switch on the light here because well, you can see it, I think. Well, on top, as you can see, I'll point to it. On top, right here, there's a slot, and you can insert into that slot something like this, which is a special plastic screwdriver which fits into the slot like this, and then you can turn, as you can see, these ferrite cores up or down, and thus influence the frequency, sensibility, or sensitivity, I should say, the frequency sensitivity of the coils. So, and you can do it on two sides. So there is a coil down here, there's a coil down here, and there's a coil up here. So there are two coils, in fact. Just on the top of my head, I don't know which coil I mounted exactly, although let me see. On the schematic, I think the coil I mounted, is this one. I unmounted this coil assembly around the 1R5, I think. Let me see. Oh no, sorry, I unmounted this coil. Now that I see the tube numbers, I unmounted in fact this coil. And as you can see on the schematic, there you see the two coils. Yeah, and if I put the IF can below it, well, you see there's a coil up here and there's another coil down here. Well, this is represented by these two coils on the schematic. Now, as you can see, in parallel with each coil there is a capacitor here. By the way, the coils, according to the schematic, should both measure 26 ohms, which we'll measure in a moment. Now, these capacitors have no value inscribed, absolutely none. No voltage tolerance, no capacitance. Now, speaking from experience, when I repaired the Motorola, I went for a more or less standard value for these capacitors, which tend to vary between roughly 30 picofarads and maybe 200 or 300 picofarads. So I took a standard value of 100 picofarad for these capacitors, and it worked rather well. So that's exactly what I'll do with this IF can. I'm going to use exactly the same thing. Two 100 picofarad capacitors rated at 150 volts, just like pretty much all the other capacitors are rated. Okay, so what is the next step? Well, oh yeah, let me measure the resistance. Let me measure the resistance of the IF coils. Okay, so I'll take, hang on, because I really hate that tally. It's always politics, 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 and if there's one thing I don't like, that's politicians. Okay, well, so I will make a measurement of the resistance of the IF coils. Okay, hang on. And I need two alligator clips to make my life a bit easier. So here you go. Alrighty. So well, here we go. You can see the multimeter over there. So what I'm going to do is connect the leads of my, I set my multimeter on 200 ohms, which should be plenty, since they are supposed to be only 26 ohms. Okay, so let me see. Okay, well, I'm not sure, but I think this is one way. Yeah, this is one way of connecting it. I don't know what's happening. My multimeter is flashing all sorts of values back and forth and back and forth. So, well, honestly, I don't know what's happening, but in my opinion, it's those capacitors which are in parallel with the coils that provoke that sort of reaction, as you can see, because the measurement says now it stabilizes around 73 ohms. Now let me see if I reverse the coils, the crocodile clamps, and I put them on the other coil. Yeah, so I put them on the other coil, and that one jumps back and forth a little, but it centers around 70 ohms. Well, maybe a bit less, 69. So they are more or less equal in value. I mean, equal in resistor value. Albeit it keeps jumping back and forth a bit because the AD converter inside the multimeter is also noticing that there is a sort of short between the clamps due to those defectuous capacitors. Yeah. just for safety purposes, or to be certain, I measure it in the other direction too. That doesn't give anything. Okay, so there's no cross short. Okay, so the values, if not correct, I mean the values that I measure are around 70 ohms, let's say, while the schematic calls for 2 coils of 26 ohms. Now, like I said, the capacitors inside the base are probably the culprits. Yeah, they probably cause a kind of a short, which sends the multimeter into a fit. So anyway, what am I going to have to do now? Well, if you take a good look at the base of it, if you take a good look at the base of the IF can, you can see, if I can make it focus properly, you can see a copper tab sticking out. Now, what is happening, or what is inside of this, is that let me stabilize my camera a little bit. What is the case here is that this base here, I need to focus it a little bit. Okay. You see the base here is comprised of 2 plates. So you have the actual base itself, which is this, and then on top of the base you have another translucent, or I should say transparent plate, plastic plate. And in between those 2 plastic plates is sandwiched a mica capacitor, which you see glistening here in the light below that red mark. Well, and there's probably another one here, although it's less visible because of that black and blue color. But anyway, what I need to do next is to find a safe way to take away this top plate so that I can go underneath and remove those defectuous capacitors which are underneath. And that's going to take quite a bit of work due to the fact that the construction of these IF cans is quite different from the construction of the IF cans I repaired or refurbished in the Motorola. So yes, it's going to take quite a bit of extra work, I think. Alright, so just give me some time to figure it out, and I'll be back with another update when I'm set to completely disassemble this IF coil assembly. Alright?